Okay, so let's start our lecture today. Um, uh, so last time we end up with the case where so we start with so we are studying we are trying to figure out the case where the L is bigger than K, where L is the amount of barrier. The barrier length. So let L be the barrier length. And then we focus on the case where L is bigger than K, and also this K does not divide L. So and then we also assume that L is equal to we have L is equal to CK plus R for some remainder. So where these are all positive. So in a graph, we have that. So this is like K to K, and then we have the omitted points here, and then we have the lengths. Yeah, looks like X here. Okay, and then we have so this is like the X here and X here. So what we have last time is that we have the sum as so we have the sum as L bigger than K, and which K doesn't divide L. This is L, which is equal to. So first, this is like the horizontal sum. So n from 1 to L, nk squared minus L squared over b squared over times the nk squared plus L squared. So now we plus. Sorry, last time I made a mistake about. So last time I wrote it as C here, but I think it should be C minus 1, because if we start with C, then I have to sum up with the remainder. So it has to be C minus 1, because I want to sum over. So for example, if I consider like an L like here, so then in this case, this L is between like a 2K and 3K, right? So here for the C, right? So basically, I want to sum over this part and this part. So these are like the multiple of K part, right? And then plus some remainder. So for the remainder part, it won't sum over the whole section, right? It only sum over part of it. So I want to just take this out for a while and then just sum over the previous whole sections. So for the previous whole sections, so here I start at 0, right? So basically, I'm running through this one, and then for this part I'm start at k, right? So I'm and then and here, right? So this is like when there is like ck, right? So this L is like ck. So here, when we reach the final bar, the final like count of the k, then we are gonna be counting the remainder, right? We're gonna counting the remainder after this. So here, before the remainder, we wanna stop at c-1 in order to count towards the whole section before the remainder part. So what we have is that, so we have this one over the double sum of j from, so ik plus 1 to I plus 1k minus 1. And also we have the lk squared minus j squared over b squared lk squared plus j squared squared. And then what we have is that we have, so now we start with the last one, right? So when we start with the last one, what we have is that so we just start with the j, where j goes from the last count, so which is ck plus 1, right? And then all the way through the remainder r. And then, so similarly, right? So here, this is like the n, and then this is like the m. Sorry, this is like the j. So on the barrier of length L, so when we are sum over like the vertical part, right? So this is like the horizontal part. So when we sum over the vertical part, what we have is that we are having the we are sort of fixing the horizontal, the x value, right? We are fixing the x value. So here we're fixing x value to the L k squared minus j squared over b squared lk squared plus j squared. Again, I think we want to sort out the denominator, right? So we want to sort out the denominator, and no, like for the denominator, what we want is that we want to have the denominator as a common lowest bound, right? And then for the numerator, we want something up. So let's just do that. And then let's say we have b squared times nk squared plus l squared. So let's say we have the lower bound as lower bound for, wait. So let's say we have a so let's consider the numerator part. So for this one, what we have is that we are having so we are summing over the n here. So n is being summed from 1 to L, right? So when we have when the n is summed from 1 to L, what we have is that so we want to use the formula here, the formula for the formula the formula for the sums, so we have so L plus 1 2L plus 1 over 6 times k squared, and then this is exactly L copies, so minus L cubed, and then so the second one we have so for each j, so what is the sum for each j though? So we can break it into like two parts, right? So one part is sum from so this sum basically, right? So if you fix the I, and then this sum, so the sum over the I is given by through I plus 1 k minus 1. So this sum is equal to the sum of the sum through the upper one. So j from 1 to I plus 1 k plus 1, sorry, k minus 1 minus sum from j from 1 to ik. So which is equal to, so for the upper one, what we have is that we are having so this lk square is being the lk square is I think it's what is lk square? Oh, yeah. So lk square basically is being multiplied by yeah, I think it should be k minus 1, right? So k minus 1. So oh wait. So yeah. So here, right? So here so this is being summed totally I plus 1 k minus 1. So it should be I plus 1 k minus 1 times the first one times lk squared, and then minus. So now for the j, let me think. What we have is that we have for the j, what we have is that so j is j is what? J is exactly the so what is j? What is j? So So J basically, I get it should be yeah, so it should be I plus 1 k minus 1 times I plus 1 k times it should be 2i, so 2m plus 1 should be 2 times I plus 1 k minus 1, right? Because if you multiply by the whole thing, it should be 2i plus k minus 2, and then I add 1 to this one, so it should be minus 1. And then it should be divided by 6. Yes. And then, so the other part, so for the other part, I think for the LK part, right? So the LK part, I think is the same. So if we have just the sum over IK, then it should be totally like LK squared times IK, right? So LK squared times IK times LK squared times LK squared, and then minus. So when we have the minus, what we have is that minus J squared. So for the J squared part, what do we have? So when the J goes from IK plus 1 to I plus 1k minus 1, what we have is should be IK times IK plus 1 times 2IK plus 1 over 6, right? Let me see. Oh, yes. So so this one is equal to, let's see. This one is equal to so here for the first one, what we have is that. So let me just expand the amount here, and then IK plus k minus 1 times LK squared minus so this is 6 over okay, so this is IK plus k minus 1, and then this is why it's like just IK plus k, and then this one is 2i. Oh, okay. So 2ik plus square k 2i k plus 2k minus 1 and then this one is same, and then this one is equal to minus so here I have a ik squared plus ik times 2ik plus 1 over 6 and then let me just delete over I just add over 6 and then so I think this ik is being cancelled out, right? So this ik is being cancelled out. What we left is that we are left with just so here for this one, what we have is that let me write on the top, and then this one is ik squared, and then this one is plus ik squared. Yeah, and then we have plus another ik squared, and then plus k squared. I shouldn't use I really, but yeah. So because I think this time there's only the real part, right? So there's no danger of confusion. So let me see here. So this one is k squared, and then minus ik minus k, and then we have we have that the so this one is what? So let me just expand on this one. So this is equal to, let me write it here. So we have 3ik cube, sorry, 2ik cube, and then plus ik squared, and then plus 2ik squared, so plus 3ik squared, and then plus ik, here, so this one, so basically this one is just the top, right? Just the top one. So and yeah. So it's a top one, and then for the after you sum the second one, what we have is that we are having so so let me just maybe simplify it by a little. So first one is plus 2ik squared, right? So there should be a 2 here, and then k squared minus ik, okay? And then so this whole thing times that I have so I will have 3ik squared. 3ik cubed, and then cubed, and then we have that this is so this is the 2ik wait. So this is 2ik plus 4 I wait, what is that? So plus 4i cubed, 4ik cubed, and then minus 2ik squared, and then and then plus 2ik cubed. Let me write it here. 2ik cubed. Oh, so I think it should be cubed. And then plus 2k cubed, and then minus k squared, and minus 2i squared k squared, and then minus 2ik squared, and then plus ik, and then minus 2ik squared minus 2k squared plus k. So totally I have the so what I have here is that I have, so what do I have? So I have so here, this whole thing is being minus, right? So this whole thing is being subtracted. And wait. Did I mess up something? So I think each one should be plus, right? Because yeah, so because we are minus wait. Yeah, so we are minus the j from 1 through ik, right? So when j from 1 through ik, so this is the difference, right? So we are summing over this difference. Sorry, we are summing over this difference and then subtract this sum. So therefore, when we subtract this sum, this becomes a plus. Yeah. So this should be a plus. So this is the term that I erased about this one. So so when we have a plus here, so what do we have? Oh yeah. So so let's do some calculation here. So here, this is the minus, right? So this is a plus, so I should cancel out. So this 3 becomes 1. And then ik squared. Do I have the ik squared? So here, this is 1 I squared k squared, right? Is there another ik? So I don't think there's another I squared k squared. So therefore it becomes a plus and then so this is the ik. So is there ik here? Yeah, so these are cancelled out. Wait, I think I made a mistake. So originally it should be minus 2, right? So, yes, I think it should be minus 5. Because, yeah, it should be, yeah, because, yeah, it should be minus 5. So, yeah, it should be a minus 5. So then, so we have that. So we have so here these two can be combined. Okay, so we have 6, right? So here these two can be combined. So 6 ik cubed, and then so let me just can bring out right this one, and then minus so minus 4 ik squared. So this comes out, and then oh wait, shoot, okay. So it should be minus 6. So there's another one. And then what we have is that so minus 5 I squared k squared, and then minus 3k squared. Out. And then plus 2k cubed plus k. So whole thing over 6. Okay, so so these are for each I, right? So then we sum over the i's. So what do we have? So so when we sum over the i's, when we sum over the i's, what do we have? So So what do we have? So we sum over the i's. What do we have? What do we have? So we sum from I from 0 to c minus 1 of so the first one is k times lk squared minus lk squared and then minus. So so here this is just c copies, right? So basically, and then there's no I here. So basically I can just multiply by c. And then minus sum over i's of over 6. So there are some terms that involves I, right? So let me just pull these terms out. So there are a couple of like i's, and then there are like some I squared. So there is like a ik cubed. So plus 6i k cubed minus k squared, and then minus 5i squared k squared, and then so then it will be, so let me just pull this out. So minus, let's say c times negative 3k squared plus 2k cubed plus k. Okay, so yeah, so this one is exactly the, so this one is exactly the sums. So yeah, so here this sum doesn't include this one. Okay, so this sum is just this part. I'm like because there's no I like towards the last three parts, so I just pull separate out. Okay, so right now let's see. So yeah, so this one is just k, right? So this one is just k. Let's see. Do I have time? Okay, I have a little bit of time. Okay, good. So yeah. So right now, let me see. So I have. So this one is. Let me just sum over this part. So so I need to find a way to sum over the cube, right? So this one is equal to what? This one is equal to, so let's see. So this one is equal to minus 1 over 6 times this sum, right? So for this sum, what do we have? So I think I need to use the cubic sum formula. Let me see. So for the cubic sum, let me see. So cubic sum, what do we have? So for the cubic sum, let me check.
So let me just search a little bit.
Oh, I see. So, this one is equal to, so it's equal to, so sum from, so this one is equal to so so there's like a formula formula about the sum as yeah. So there's a formula. There is a formula about I from 1 to let's say c of like I cubed is equal to n c times c plus 1 over 2 squared. So I want to use this formula. So however when we have however what I have here is that I have just the sum from the sum is from 0, right, instead of 1. So what I want to have is that we have if we start at 0, yeah, maybe we can subtract. We can start with 1 and then subtract the c from the sum. So let's say, so we have so this is equal to 6 times sum from 1 to c of this one of. So let me just analyze the case where the ik is ik cubed. It's from 1 to c, because when I equal to 0, it is this term is exactly 0, so it's exactly 0. So therefore we have, so this is equal to from 1 to c minus, we have the c cubed, k cubed, and then what we have is that we have so this guy, sorry, and then minus, let me see. So yeah, so this is like this one, and then plus the rest part, sum from I equal to 0 to c minus 1 of 6i k cubed minus k squared minus 5i squared k squared so what do we have? Yeah, so this is square here. So this is equal to c times c plus 1 squared, oh sorry, over 2 squared k cubed, and yeah, so minus c cubed k cubed and then so this one I can use the formula for the first power sum. Yeah, I can use the formula for the first power sum. So I have plus so the so so c minus 1 plus 1. So I am assuming that this sum start at 0, sorry, start 1 and end at c minus 1. So therefore there is total c minus 1 term. So the first term plus the last term times the number of term, which is c minus 1, and then over 2, and then times 6 times k cubed minus k squared. And then, so we have the 5. And then minus 5k squared times c minus 1 times c times 2c minus 1 over 6. And then this is negative 1 over 6. 1 over 6 here. I think I'll stop here today, and I'll continue next time. Oh, sorry, I think it's not well recorded here, so.